Hi guys, we are now doing 1.2 or unit 1, lesson 2. We're going to take and solve some of these problems, but they're going to be in application or word problems. Okay. So the first thing I want to do is remind you how to solve an equation for different variable. All right. So in this case, we have Fahrenheit equals 9/5 Celsius plus 32. What if we wanted to solve for C? If that was the case, then I want to isolate C, okay? I wanted to say C equals. So I get rid of things added or subtracted to the term that has C. So in this case, 32 is added, so I'm going to get rid of it by subtracting. I can't take F minus 32 because I don't know what F is. So I just write F minus 32, okay? I can't actually do that subtraction. Then I'm left with 9/5 times C. To get rid of anything multiplied by C, I divide by it. Now, dividing by 9/5 is the same as multiplying by 5/9. So I'm going to multiply the F minus 32 by 5/9. And that will be the equation solved for Celsius. Okay? So you do the same inverse operations, just sometimes you can't actually do the operation because you just have a variable instead of a number. Okay? In this case, we want to solve for P, and there are two different P's in this problem. So you get to do one of your most favorite things, guys. Hold back that excitement. We get to factor. So I'm going to take P out, and that'll give me a 1 plus RT left. Okay, so I have S equals P plus PRT. I factored the P out. And then notice if I would distribute that back through, I'd still have P plus PRT. Okay, I just have it in factored form so that I just have one letter P. I'll divide by the stuff that's multiplied by the P, which is 1 plus RT. Divide both sides by that. Okay, and that's my equation solved now for the letter P. P is S over 1 plus RT. When it says solve for P, that means we want an equation that just has P equals blah, blah, blah. All right. So sometimes you'll have to factor something out. This is a tough one, guys, when you have the variable that in need is in the denominator. Sometimes people mistakenly think that you can just flip everything. For example, I know that 2 plus 3 equals 5. That is the truth. That doesn't mean 1/2 plus a third is a fifth. No. Okay, that doesn't, you can't just flip things around. No, no, no. So what we're going to do is get a common denominator. I like to multiply everything by the common denominator sometimes as a different strategy other than rewriting them all with the same denominator. So I'm looking and I see the common denominator would be R times R sub 1 times R sub 2. Those are all different variables. We use the same letter sometimes with a little subscript just because all those R's represents resistance. This is a formula used in electricity. So there's resistance for one, a resistance for another circuit, etc. So these still use R, but we use sub 1, sub 2. Just get used to that little subscript there, okay? Anyway, I'm supposed to solve for R1. So eventually, I want it in the numerator, so I'm going to multiply every term by the common denominator R, R1, R2. When I multiply 1 over R by R, R1, R2, the R's cancel, and I just have 1 times R1, R2. Sorry, let me just erase that. Somehow my pen's giving me some trouble here. Okay, and then when I move to 1 over R1 and multiply that by the same common denominator of R, R1, R2, this time the R1s cancel, and I just have R, R2. And when I multiply 1 over R2 by this common denominator, the R2s cancel, and we have R times R1. Okay, now I'm solving for R1. here's a term that has R1, and here's a term that has R1. Let's get them all on the same side. So I'm going to subtract the RR1 over to the left, leaving just the RR2 on the right. The reason I wanted them on the same side is so I could do what I did on the previous slide, which is factor. I'm going to factor out the R1. And then after I factor out the R1, I'll be able to divide by the R2 minus R that's multiplied by it. And my final answer is that R1 equals RR2 divided by R2 minus R. Okay, again, we had to, there's a lot going on here with these rational virtual equations, these rational equations, okay? And we wanna, you just have to be careful. Don't do the common mistake of just flipping. Multiply everything by the common denominator. That'll clear your denominators. In this case, I had to get all my terms that had an R1 on one side and then factor out and divide. Okay, now we're back to the beginning. I hope you watched the lesson overview. That's where we started. The reason we practice solving equations is so we can solve real life situations like this. I have only 30 bucks in my pocket, okay? And I know that I want to buy something, and I know I could spend a little more than 30 because it's a 15% off sale, but I don't know exactly how much more I can spend. Like, what could the thing actually cost? And I could still buy it with my $30, okay? So I think about what this means. However much, let's just say I have something that costs $40. I'm wondering, can I buy it with my $30? Well, I'd have to take 40 times 0.15, right? And whatever that is, I would then subtract that from 40, right? So in other words, I'm going to take the $40 that it cost. I'm subtracting 15% of 40. And then that'll tell me how much this will actually cost. Okay, so 15% of 40, what would that be? $6? 40 minus $6. This is actually going to cost, this $40 item will cost me $34. So, oh, I can't buy that. Well, I don't want to keep doing this. I want to actually find out how much I can spend. So what I don't know is the $40. Okay, so I'm going to let $40 be X. X minus 15% of X, that can't go over 30, right? I only have $30. X minus 0.15, so that's 1X minus 0.15X, that's 0.85X. So my last step would be to take the 30 divided by 0.85. Get your handy dandy calculator. Let's see. 30 divided by 0.85. 35.29417765. Well, I'm just going to round that to 35.29. So I have to make sure when I'm shopping that I don't go over $35 and what was it, 29 cents? So I'll just, $35 I might just round to just to be safe. Okay, so that's how we do that. What most people do sometimes is take 15% of 30. And we don't want to take 15% of 30. We want 15% of whatever it costs. I know that I can actually buy an item worth $35 and I'll still have enough money. Okay, so again, notice how we use some real numbers just playing, and then we set up an equation, combined our like terms, divided. We're using all the strategies we've learned, but we're using them to solve real life problems. When you're solving these real life problems in this section, this is just a little guide. You want to make sure you read and totally understand. And that's where we get into trouble more often than not. When I say by we, I mean me as well. I read quickly, I look for numbers, and I don't maybe answer the actual question. That's why some people will take 15% of 30 in that last problem. Sometimes I make a sketch if it's like an area perimeter problem. I use variables for the unknown values. I'm a big fan of X, but you can use, some people use the first letter of their name all the time, whatever you want. Write the equation, solve the equation, and then check your answer. I know I didn't do that on the previous one. I should have. Okay, for example, a group of hikers went down the Grand Canyon. It took them 3 hours and 30 minutes. Okay, they came up a different trail, which ended up being 4 miles shorter, which was nice, but they actually climbed 2 miles per hour slower because, you're going up. You can't go as fast when you're going up. And it ended up taking them an hour longer. What was their rate going down? So this is your typical distance equals rate times time problem. Okay, so let's think about the distance going down. The distance going down is how fast I was going down times the time it took me to go down the canyon, which was 3.5 hours. All right, we're going to change this. I don't want to deal with hours and minutes. All right, I want either all hours or all minutes. And I'm choosing hours. I'm going to say 3.5 hours. Okay, that's my distance down. My distance going up looks like, I don't know how fast I was going either, but I do know it was 2 miles per hour slower. So if I was going 6 miles per hour going down, I was going 4 miles per hour going up. Whatever it was going up, or whatever it was going down, I'm 2 miles per hour slower. So I'm going to have the rate be r minus 2. The time was an hour longer. Well, I guess that's 4.5. I already knew the time was 3.5 to go down, so I guess it was 4.5 to go up. So I have the distance going down, and at first I want to set it equal to the distance going up, but then I remember the distances weren't the same. When I came up, that was actually 4 miles shorter. So if I want to take the distance down, and I would like that to be equal to the distance up, I'm going to have to add 4 to the distance down, then that would make them equal, or subtract 4, or other way around, I'm sorry. I'm going to have to add 4 to the distance up, right? Because right now, what they already said, the distance up is 4 miles shorter. Okay, so the distance up is smaller. So if I want it to be the same, I'd have to add 4 to it. Or I could subtract 4 from the distance down. I'm going to do that. Okay, I know that the distance coming up was 4 miles shorter. So be careful because of that, people want to take the distance up and subtract 4. That's going to make it 8 miles shorter. Okay, we want them to be equal. So be careful where you add or subtract 4. Okay, and now it's a problem ready to go. I'm going to take my 4.5 through. I'm going to change that to 4.5 if that's okay. Oh, sugars. I didn't mean to do that. Oh, shoot. Can you let go? Okay, so I will distribute through. I have 3.5 r minus 4. I'm going to change the decimal here. It'll be a little easier to write. Equals 4.5 r minus 4.5 times 2 is what, 9? I'll subtract 3.5 from 4.5. That gives me 1 r. I'll add 9 to negative 4. That gives me 5. So what was the rate going down? 5 miles per hour. Okay, because that was what I was letting r equal, was the rate going down. How fast was I going up? 3 miles per hour. Okay. And then this pool problem. It's time to drain the pool. The neighbor's pump drains it in 5 hours. My pump drains it in 8 hours. How long if I run them both? This is very similar as we want the rate per hour. Okay, so if it drains the whole pool in 5 hours, it completes the job. It's 1/5 of the job per hour, right? It'll do 1/5 of the pool per hour. The other one will do 1/8 of the pool per hour. Kind of want a rate per hour, just like on the previous problem. Okay. The time, right? We take rate times time to get the whole job done. So I don't know. That's what I'm wondering. How long? Okay. So we will continue that on the next video. All right. See you in a couple.